Okay, so this is what you call the clearance, and based upon the clearance value, the amount of depth which has been interference, that gear's interference distance has been mentioned with the help of their hole depth or otherwise the given clearance value. So their formula of clearance is about 0.157 divided by diametral pitch. Wherever this case 0.05 into circular pitch has been used in order to determine how much amount of clearances has been made in my gears calculation. And second one, we need to find out what is the outside diameter of the gear, and similarly what is the inside diameter of the gear. If you're going to find out what is the outside diameter, we need to calculate teeth plus 2 divided by diametral pitch. In turns, teeth plus 2 into circular pitch divided by pi. It is for the calculation of two different sizes or otherwise their tooth alignment which has been varying. It may be a non-intersecting and non-parallel element. Okay, if you take a case of diametral pitch, we need to know that teeth plus size of the value or the size of the depth is nothing but teeth plus 2 plus outside diameter in terms of diametral pitch, or otherwise we can also written as an teeth plus 2 divided by diametral pitch of the outside gear circle. Okay, so based upon the pitch circle diameter and the module, we need to find out what is the diametral pitch along with that outside diameter. Okay, and when we talk about these all kind of formulas, first of all we need to know what are the gear materials which we are normally using. Okay, in order to find out their power transmission, in order to find out the power transmission application depends upon the type of the material, the gears usage application has been varied. Okay, for example, if I am going to select the material of the gear with respect to their strength and service condition like wear and noises, okay, the selection of materials is purely depends upon strength and service conditions like wear and the noise. And the point number 2, metallic components like cast iron, steel, plain carbon steel or alloy steel and bronze. This metallic materials has been calculated based upon this value. And the non-metallic materials generally it is used for reducing the noises. Along with that, help of materials is what you call that wood, compressed paper and non-synthetic resins like nylon. Okay, so the non-metallic materials is little bit different when compared to the human. Okay, for example, that non-metallic or human-made metallic, it is little bit different when compared to human-made gears, that is an plain carbon steel, or otherwise if you are using the alloy steel and bronze. Okay, this non-metallic materials can be used for reducing the noise reduction. And note that phosphor bronze is widely used for worn the gears in order to reduce the wear of the gears. Okay, they are used their phosphor bronze. Okay, it is one kind of important question. Phosphor bronze is widely used for women gears, that which is worm gears, that in order to reduce the wear of the worms. Okay, it is totally based upon the type of gear materials. Okay, so in the upcoming class we just seen about the conjugate teeth. So here I am going to touch what is meant by log gearing and what is meant by conjugate teeth. The moving point P, which is if you are going to trace the moving point P when there is a meshing takes place, it can create one direction which is in angular to the tooth point of contact. Okay, that profiles which gives the constant velocity ratio along with that positive drive is known as conjugate profiles. Okay, the length of the path of the contact and the path of the approaches and the path of the recess which has been calculated is purely based upon the amount of teeth in the point of contact. Okay, we will continue on next session.